Hello, Professor Dever. My name is John Butler, and I'm a student at Challenge, and I'm going to discuss the questions that you have posed us to do. The first question that you posed us to do was to explain what a one-to-one function is. In a one-to-one function, every value of x has exactly and only one value in the codomain or the range in which it corresponds. For example, if we had the value of a, which is the input value, or x, the domain, if we had a value of a and we put it into a function, let's say function f, then when you get that result, it'll only equal one number, and let's just say it equals 1. However, a cannot equal 1, and a cannot equal 1 and 2. And this also means that for every y could only correspond to every one value over here. Because if that was not so, then it could be more than one. So, for example, b can correspond to that, g can correspond to 3, and c can correspond to 4. However, in a one-to-one function, it doesn't have to be on 2, which means that every value in y does not have to equal an x value. So just because we have however, all the domain has to equal something in the range. However, every element in the codomain does not have to equal have to equal some thing in the domain. And if we go over here and we see the graph x plus 1,
you can see that the line is this.
And with the horizontal line test, which goes only through the y-axis, it'll show you that no matter how many horizontal lines we draw, and that's a bad one, it'll only hit 1 point on each of these horizontal lines. Which is another reason, this is another way to show that it is one-to-one. However, with the equation x squared minus 1, start here, and then go here like that. When you do that, this is saying that for any polynomial where x of n and n equals n is greater than greater than 1, so if it's 2 or more, greater than or equal to 2, how about that? When it's greater than or equal to 2 and a of 2 is not equal to 0, then that would mean that there would be an equation like this where when you put the horizontal line, it is not one-to-one, which means that for every y value there is 2 x values in which the y value can correlate. So at y equals 0, you can have either 1 or negative 1. So that means it's not one-to-one. Now, for here, we're trying to. Now, you also want us to find the inverse, and to find the inverse of a function, let's say the function is let me see. The function is x squared, and you draw x squared. I'm about to draw right now. Draw x squared to look like this. The inverse of said function would be that function flipped over the y equals x line. So this would come over here. This would come over here. This point would stay, and you would have something like this. That would be the new graph, because it would flip directly across that line. To find the inverse of a function, you would first change, sorry about this, make it more clear. You would change the f of x to y, and then you would solve for x. So first I subtracted the 5 to both sides, and I got y minus 5 equals y minus 5 5 equals this. and then I complete the square and whatnot, and eventually I got to square root of y plus 4 minus 3 equals x. And then once you do this, you substitute the y and x back again. And then this is the inverse of the function. Y equals the square root of x plus 4 minus 3. So like I said, first you change that to y, and then you solve for x, and then you go back and replace the two terms together. Now the second question that you posed to us was to explain how tangent x is not one-to-one over all the intervals. And so when you think about all the domains, you think about every point. And so the domain of x to y is, the domain is x is equal to pi over 2 plus pi, or well, any real number. And so the domain is in between all the points which that is true. So negative pi over 2 plus pi, which is a real number, plus 1 pi will give you pi over 2. So when you have this as a function, you can go over all intervals. You can see that even though it is undefined at these points right here, you can still draw a horizontal line which makes that function not one-to-one. However, you still see that the function is, if you want to find the inverse of the function, you have to restrict the domain so that it is one-to-one. And when you restrict the domain, you would choose which intervals is the function either completely increasing or completely decreasing. And between every pi over 2 plus pi times any real number, that function is true. So the easiest interval to choose would be from negative pi over 2 to pi over 2 for tangent. And I'm going to draw a tangent right now. And from here, you can actually create a function that is inverse of this. So when you have a domain that looks like this, x, the properties of x is that x equals any interval in which that is true. I'm sorry, the x cannot equal any function in which that is true. And in R, as you see, the R would be the range, and the range is all real numbers, or from negative pi to negative infinity to positive infinity. However, when you want to find the arctan of that, which means arctan is the same as saying tan to the -1, you reverse what you call the domain and range. So the domain now becomes the range, and so negative pi to pi is the domain, and the range would be this. Would be that. However, whenever you do it, the domain is restricted over one interval, which is negative pi over 2 to pi over 2. As so. So as you see, this is the inverse of tangent. And that can help us in a lot of ways. For example, if you are given the answer 1 for tangent, you can look and you can find where on this interval 1 is equal to the radians in which the angle is. So that's how you can do that. And like I said, the domain and range of a arctan is, the domain is negative pi to pi, and the range, although the range flips with that, you just choose one. For the math only lets us choose one, so we choose negative pi over 2 to pi over 2.